Hello everyone, in this video we will build ERC-20 smart contract token using OpenZeppelin library from scratch. We will test it and deploy it on Rootstock test network. So Rootstock is Bitcoin sidechain and it is EVM compatible, which means we can deploy smart contract on Rootstock network using same tech stack and same language like Solidity, Viper, and same Ethereum tools like Foundry and Hardhat, Remix, and so on. So here we are on rootstock.io. Let me tell you what makes this rootstock different from Ethereum is that it is more secure, faster, and cheaper than Ethereum, and it uses Bitcoin's hash power to secure the network by merge mining. If you want to learn about merge mining and opaque these concepts inside this rootstock, you can go to rootstock.io, and inside the build you can go through documentation, and inside the learn you can learn about opaque and merge mining. You can also explore RBTC ecosystem and the community. They have ambassador program. Also they have rootstock activator program which is live currently. You can contribute and earn rewards in rootstock. So without further ado, let's get started and start building our ERC20 smart contract. Let's create new folder on our desktop. Let's name it rootstock ERC20 and open this folder in our VS code. Here we go. And before going ahead, make sure you have Foundry installed in your system. For that you can go to book.getfoundry.sh, and here in installation you can install it according to your system. So let's get started. We are going to initialize new project by command for init, and here we go, our project is initialized. And as I said, we are going to use OpenZeppelin library. So let's install OpenZeppelin. This command for install OpenZeppelin slash OpenZeppelin dash contracts dash no dash commit. And while it is installing, let's delete these three files, counter.t.sol, which comes with our project. And here we go, and we have successfully deleted. And let's create a new file inside the src directory and name it MyToken.sol. and you can see our project OpenZeppelin library is installed. So let's write it down and let's start writing our smart contract right here in MyToken. Before writing smart contracts, let's create our remappings. This command forge remappings remappings.txt, and you can see new file as created, remapping.txt. So let's start writing our smart contract. SPDX license identifier MIT pragma solidity we are going to use 0.8.19, and let's name our smart contract MyToken, and let's create a constructor, and inside that constructor we are taking as an argument, as an initial parameter, initial supply, and here ERC20, inside that let's name it, I'm going to give it my name, and the symbol is let's say PDT, and it is giving us a warning because we have to make our smart contract is ERC20, and we have to import it from OpenZeppelin ERC20, not yeah, from at OpenZeppelin contracts and contracts, sorry, token, I guess, yeah, token, and inside that token ERC20 and ERC20 that's all you can see here. And inside that we are going to call this mint function. I will show you where is this mint function, and inside that mint function we are going to call two arguments, message dot sender and initial supply, that is here, and here we go. So I will show, I'm just formatting this document. I will show you where this main function coming from. This main function coming from this OpenZeppelin library we have installed. Inside you can see contracts, and inside that contract we can see token, and inside the token ERC20 and ERC20, that's all. Let's search here. Let's search here mint, and here is, you can see we are passing the message dot sender and event to fixes as initial supply. So we have our smart contract ready. It's time to write some test and let's test it. So for that we are going to create a new file inside this test file, and let's name it MyToken test.t.sol, and let's start writing test pragma solidity, yeah, thanks to copilot 0.19, and it's MIT, and let's start writing test or contract MyToken test is test, and we have to import test from Forge standard library. So let's import test from Forge standard library first, and test.sol. We also have to install we also have to import our MyToken. So let's import it. Import MyToken from not OpenZeppelin. It is because it is inside our SRC directory, and here we go. Let's set up our function. Before setting up our function, let's declare our some state variables. So MyToken, which is this is, and let's make it public. Oh my god, my bad. And this should be token. Let's declare address public owner. Let's address public user. Let's uint. This time we have to make it constant. Uint 256 public constant. Let's make it initial supply. Let's say 1 million token, right? So is equal to 1 million token into 10 to power 18, and let's say function setup public, and let's set up inside the setup function. Let's set up a MyToken, not a MyToken. I am my bad. Owner is equal to address this, and let's say user is equal to address 0x1, right, and let's say token is equal to new MyToken, and inside that MyToken we have to pass this initial supply, right. This is coming from here, and now let's start writing a test and test our functions. For that we are going to run the first test, and let's test initial supply. So let's write function test initial supply public, and inside that let's assert equal, and the left side is token dot total supply, and on the right side let's pass this initial supply, right. And again assert equal to, on the left side token dot balance of, and inside that we have to pass owner, and the right side same as the initial supply. My bad, I made something wrong here, I guess. Yeah, there we go. Let's test our first function by running forge test, and let's hit enter, and yeah, you can see here our first function is first test is fast. Okay, let's write our second function, and let's test transfer. So for that let's function test transfer transfer, and it is gonna be public, let's declare a local variable and emit to unt 256. Let's name it amount, and is equal to, let's say 1000 multiplied 10 into power 18, and bool success is equal to token dot transfer, and inside that we have to pass user and amount. If you don't know these functions, where this transfers, where this total supply, where this balance of function coming from, you can go to OpenZeppelin library, and as I said, inside that you can go to token, and inside that token ERC-20 token, and you can find all this function there. So there is no need to worry about it. You can always go there and check out where these functions are coming from. I just know everything, that's why I'm just going through and starting typing fast. So if you want to explore where these functions coming from, you can go back and check out these functions. So let's say assert Let's get back and start, and inside the assert2 we can pass this success, right? Yeah, and let's assert equal, and the left side token dot balance of, and inside that balance of we have to pass user this time, and the right side amount, right? And again assert equal, and the left side we have to pass same as the balance of, yeah, and but not user this time, because we have to pass owner. And the right side we have to pass initial supply minus amount. And let's say our test by running, let me clear the my terminal, and you can see here forge test. Here we go, our two test has been passed, and we are going to write our last but not least test. Let's start writing test revert when transfer insufficient balance. So function test and revert when transfer transfer insufficient balance. And let's make it, oh my bad, let's make it public function, because all the tests you write inside Foundry, that functions are public. Let's declare a variable thanks to Copilot, and we have declared local variable unt256 amount is equal to initial supply plus 1, and we are going to use Foundry cheat code vm dot expect revert, and let's say token dot transfer, and inside that we have to pass user and amount thanks to Copilot. I'm just hitting tab, and let's clear it, and test our 3 test, and here we go. You can see green here, our all 3 tests are okay, and we are ready to deploy our smart contract. So for that we are going to write deploy script. Inside that deploy script, let's create a new file, deploy MyToken .s .sol, and let's start writing our deploy script. Let's say spdx, license identifier MIT pragma solidity. We are going to use same version 0.8.19. there you go, and oh my bad, 8.19. let's say contract deploy MyToken, and it is going to be script, and for that we have to import script from for standard library, import import script from for standard library, and the script.sol. there you go, let's make it script, and let's function run, let's declare function, and we have to make it public we have to start broadcasting. Inside that, vm dot start broadcast, inside that run function, and let's say we have to call mint function. That you can see inside our smart contract we have constructor, and that we have constructor argument as an initial supply, and we are also calling mint function. So for that we are going to mint 1 million tokens initially. So let's declare this unt 256 initial supply, initial supply is equal to, let's say, 1 million, or and that is 10 thanks to Copilot. And we have to also import our MyToken contract. So thanks to Copilot I imported it, and here we are passing MyToken is equal to token, and that is going to be new MyToken, and inside that we have to pass this initial supply, right? And we have to stop broadcasting. So vm dot stop broadcast, thanks to Copilot. So we have deployment script also ready. So before going ahead, we have to create new file called .env, because we are going to use our wallet to deploy our smart contract. And inside that we have to declare two variables, two environment variables, let's say private key and RPC URL to connect with Rootstock network. The private key you will get just by going to your MetaMask, and inside MetaMask you can go to account details, and you can here don't share your private key, just put your password and hold to reveal private key. I'm just copying this and pasting here inside this. Make sure it is starting from 0x, and I'm just pasting it. And for the RPC URL, you can go to rpc.rootstock.io, sign up your Gmail and get API key. You will get the page like this, and here you can create new API key, name it, and you can select network, testnet, mainnet. You can give description, and you can create new API key, and you can use this. I am going to use this one for better connection. I have this. You can also use mine. I'm https public dash node dot testnet dot rsk dot co, I guess. Yeah, this one is right. Yeah, and that's it. Make sure you have everything set up. As I said, make sure you have following the same following this tutorial in right way. And if you are on Windows or any other, if you are in Bash, make sure you can run this command source dot env and not renv, env, and that's it. After before going ahead, we have to make sure again our smart contract is compiling correctly and building correctly. Our testing, we have tested, still again we have to test it is all the test as fast to make sure. So let's run forge build, and you can see here our smart contract is compiler run successful. These are the some warnings because we are not using, this is not a huge warning, just a minor warning. So you can, let's clear it, and you can see forge test. Let's check our test. Our 3 tests have been passed successfully, and it's time to write our it's time to deploy our smart contract on Rootstock test network. So we have deploy script, we have test, everything we have. So for that, let's run the command forge script for deployment for script, and inside that script again we have this script folder, and inside that script folder we have deploy MyToken dot let's say deploy MyToken dot s dot sol, and we have to pass rpc url that is we have declared here in env file rpc url, right? So rpc url. Also we have to pass private key, let's say private key, and we have to, as we declared variables, private key, and that's it. And also make sure we have these 2 more parameters, dash dash legacy and dash dash broadcast. Also we have to do one more thing inside our Foundry project. We have to foundry.formal, we have to declare here as an EVM, I guess if I am not wrong, EVM version, yeah, that's it, London. Thanks to Copilot. Just go back to your terminal, and you make sure you are running the right command for script deploy mytoken.s.sol, and you are passing these parameters correctly: rpc url $, rpc url private key, and private key, legacy, and broadcast dash dash broadcast. I forgot to add broadcast correctly, dash dash legacy, and just hit I guess I think internal transport errors, no such a file or directly was private key. Oh, I guess I'm not passing the right thing. We have to, yeah, we have to pass dash dash. That's what I was saying. Yeah, now again we are getting this error because we have to run source.env, and now you can see here our smart contract is compiling, and it started deploying our smart contract on chain. Let's wait for some time because it takes some couple of minutes or less than minutes. You can see setting of one EVM, and it is the transaction is pending, waiting for pending transactions, and let's wait for some moments, and it will be deployed on Rootstock test network. Let's wait for some time. It's 19. Meanwhile you can go to rootstock.io, and here you can explore all this stuff. And if you want to explore the Foundry and Rootstock documentation, you can go to and follow this tutorial as well. And if you find anything struggling in this tutorial, you can go to this Rootstock Foundry starter kit. They have very clear and concise documentation. Let's come back and see. Yeah, you can see here success hash. You can see our contract address, the block, and how much gas you paid for this transaction. You can see sequence. So you can go to Rootstock block explorer and copy the contract address. Let to check our smart contract is indeed deployed or not. You can go to Google and check out Rootstock block explorer or block scout. You can check out on block scout, and here you go. You copy this smart contract address and paste it here, and no results found. But if you see the transactions are not here. Yeah, let's see, we copied the right smart contract address. Yeah, and you can see, let's go back to our Rootstock. I think we are on Rootstock testnet explorer. Yeah, you can go testnet explorer.testnet dot rootstock.io, and there you can paste the smart contract address, and let's wait for it is checking out. And here we go, we have this address, and you can see 3 minutes ago name Pandit, and symbol is PDT. This is our smart contract address, and the balance 0 RBTC, and here you can see block ERC20 smart contract, and the total supply is this much we have invented initially. So thanks for watching this video. In this video we deploy smart contract using Foundry and OpenZeppelin libraries on Rootstock test network, and next video we will build we will build the interface, and I will show you how to interact with your smart contract, and entirely how we can build a full stack DApp on Rootstock test network. We can also, in upcoming videos, we can also explore the DeFi, how we can build DeFi application on Rootstock network. Thanks for watching, and I will see you in next one.